Hello learners, I am Dr. Subodh Kesharwani working with Indira Gandhi National Open University in School of Management Studies. The topic which I am going to talk today is methods of time series, and we have already have a very thought-provoking session which revolves around the time series, and today we are talking about certain methodologies which are going to play a very important role as far as time series is concerned. So what we have observed that while watching the news you might have noticed the reporters saying that the temperature of a particular city or a country has broken a record. The rainfall of some state or country has set a new bar. How can they know about it? What are the measures they have taken and studied to say so? There are time series data, you all are familiar with time series data and the various components of the time series. So in extension of our post on time series, what we have discussed in our previous session, today we will discuss how trends are measured, because measuring a time series is a very important affair and there are certain methods which are going to play a very important role, and give you an example of graphical model used to measure trends. So in the last presentation on time series, we discussed the trend is the tendency. The reason for the measurement of trend is to study the behavior of the variable in the long run. This study is only possible when the time series is devoid of all the other components. Trend is also measured to study the regular or irregular variations, which we have already discussed in the components of the time series, which is possible only when trend values are isolated, and we can now measure with the help of any of the following methods which is there. So a trend in a time series is broadly classified into three categories of long-term fluctuations, short-term fluctuations or periodic fluctuations, and random variations. So a long-term variation or a trend shows the general tendency of the data to increase or decrease a long period of time. The variation may be gradual, but it is inevitably present. So prior to going into the depth of this topic, I just want to throw a light that this is part of our third block, that is trend analysis, and we are here to talking more about the measurement of trend. So already we have talked about the time series, we have talked about the trend. So today we are going to talk about methods of measurement of trend. So in business forecasting, it is important to analyze the characteristic movements of variations in the given time series, and the following methods serve as a tool for this analysis. Number one is the semi-average method, then you have method of selected point, then freehand method is there, then moving average method is there, least cost survey square method is there, and then curve fitting method is there. So what you observe that in general we have bifurcated this whole the measurement of trend into the 6 methodologies, but it is not confined to that. In the coming days, in the coming years, you will find out that some more methodology is going to come. So anyway, we are going to just focus on semi-average method. So what exactly this semi-average method is? This method is very simple and relatively objective as a freehand method. In this method, we classify the time series data into 2 equal parts and then calculate averages for each half. If the data is for even number of years, it is easily divided into 2, and each average is then centered in the period of time from which it has been computed and plotted on the graph paper. A straight line is drawn passing through these points, and this is the required trend line. So what exactly the philosophy behind the semi-average method is that in this method we classify the time series data into 2 equal parts and then calculate averages for each half. If we go more into the backdrop of semi-average method, semi-averages is meant the averages of the 2 halves of a series, and in this particular method, thus the given series is divided into 2 equal parts, that is halves, and the arithmetic mean of the value of each part half is calculated, and the computed means are termed as a semi-averages. So if the data is even number of years, it is easily divided into 2. If the data is for an odd number of years, then the year at the middle of the time series is left, and the 2 halves are constituted with the period on each side of the mid-year. So we will take one example which can differentiate how we are going to calculate the semi-average method. So but there are certain the merits and demerits, and if you go into the depth of the merits, you will find out it is simple method of measuring trend. It is an objective method because anyone applying this to a given data would get identical trend value, and there are certain shortcomings, there are certain demerits, like this method can give only linear trend of the data irrespective of whether it exists or not. So this is only a crude method of measuring trend, since we do not know whether the effect of other components are completely eliminated or not. So this is the way of calculation. We have taken some hypothetical figures with respect to the years. So in 2014 the sales is 102, in 2015 the sales is 105, in 2016 the sale is 214, and in 2017 the sale is 110. On the other hand, 18, 19 and 2020 the sale is 108, 116 and 112. So what we have done in this case, that we have taken in this method available data are divided into two parts, usually with equal number of years on both the parts. The average of the first 3 years will be 102, 105, 114 divided by 3, which comes to 321, and the answer is coming 107. So similarly for the last years it is 108, 116, 112 divided by 3, it's come to 112. So this is the way of calculating of the simple average method. And now the second method is more different from the first one, which talks about method of selected points. And in this method 2 points considered to be the most representative or normal are joined by straight line to get secular trend. This again is a subjective method, since different persons may have different opinions regarding the representative points, and further only linear trend can be determined by this method too. So this is the way and if you are going to plot this on a graph paper, you will find out that the curve should be linear in nature and looks like this. So the plot on the data on rectangular paper, draw in best straight line to fit plotted points and select 2 points on the line, not necessarily data points, and record their values. Then substitute points into the linear equation y is equal to mxb, solve for m and b and choose the third point on the line to verify the equation. So what we have observed that this is the way by which you are going to calculate this methods of selected points. And now the third is the freehand method. So this is the simplest method of drawing a trend curve, and we are going to plot the values of the variable against time on a graph paper and join these points. Then the trend line will be drawn in such a way that the numbers of fluctuations on either side are approximately the same. The trend line will be a smooth curve. And on the other hand, there are certain disadvantages of freehand method, is that it depends on individual judgment, cannot be used for predicting the trend as the drawing is arbitrary in nature. So if you are going more into the depth of freehand concept, you will find out this is a familiar concept and is briefly described for drawing frequency curves. In case of a time series, a scattered diagram of the given observation is plotted against time on the horizontal axis, and a freehand smooth curve is drawn through the plotted points. So what we have observed, that freehand concept is a very familiar concept and is briefly described in drawing the frequency curve. And if you see this particular image, you will find out that how we have calculated this the freehand concept. And what we have done, this we have put in place of years. We say for 2012 the sales is 30, so we have put the dot here, and in 2013. And so what we have done, at the x-axis we have taken years, at the y-axis we have taken sales. So then we have plot the dot first. In the same manner we used to do it. So 30 falls in 2012, it comes here, 46 2013, then 2014 25, then 59, then 40, 60, 38 and 65. By this way we have made the dot, and then we have completed the graph on the basis of these dots. And then finally what happened, we have made the trend line. So the original data is this, and we have made the trend line, which is drawn by the freehand method and can be extended to predict the future values of the given data. So however, the method is subjective in nature. Prediction obtained by the method depends on the personal bias and judgment of the investigator handling the data. So this is the way by which we have calculated the freehand concept. And there are certain points which keep in mind while plotting the freehand concept, that it is difficult to draw a freehand smooth curve, and different persons are likely to draw different curves from the same data. So the following point must be kept in mind in drawing a freehand smooth curve: that the curve is smooth, number one, that the number of points above the line or curve are equal to the points below it, the sum of vertical deviations of the points above the smoothened line is equal to the sum of the vertical deviation of the points below the line. So by this way, the positive deviation will cancel the negative deviation, and these deviations are the effects of a seasonal, cyclical and irregular variations, and by this process they are eliminated. So the sum of the squares of the vertical deviations from the trend line curve is minimum, and this is one of the characteristics of the trend line fitted by a method of least square. So what we have observed that by this way we can keep in mind that while plotting the freehand curve we have to take into consideration these points. So on the other hand, now we have got the moving average, and this moving average is a very important the methodology as far as measuring the trend is concerned. And in statistics, the moving average is considered as a rolling average or running average, rather we can say, is a calculation to analyze data points by creating a series of averages of different subsets of the full data set. It is also called a moving mean or rolling mean and is type of finite impulse response filter. So this is the one of the important ingredients of the moving average. And variations, and as far as the variations concerned, variations include simple and cumulative or weighted forms. So moving average method, if we are going more into depth of the moving average method, a moving average is a technique to get an overall idea of the trends in a data set. It is an average of any subset of numbers. The moving average is extremely useful for forecasting long-term trends, and one can calculate it for any period of time. For example, if you have sales data for 20 years period, you can calculate a 5-year moving average, a 4-year moving average, or a 3-year moving average, and so on. So the stock market analysts will often use a 50 or 200-day moving average to help them see trends in the stock market and hopefully forecast where the stocks are headed. So an average represents the middling value of a set of numbers. The moving average is exactly the same, but the average is calculated several times for several subsets of data. For example, if you want a 2-year moving average for a data set from 2017 to 2018, 19 and 2020, you would find average for the subsets of 2017/2018, then 2018/2019 and 2019/2020. So what you have done, you have bifurcated these 4 years into a subset of 3, that is a combination of 17 and 18, combination of 18-19 and combination of 19 and 20. So moving averages are usually plotted and are best visualized. So this is one of the best way of measuring the trends and analysis. And quantitative methods of forecasting or smoothing a time series by averaging each successive group, that is number of observations of data values. The term moving is used because it is obtained by summing and averaging the values from a given number of periods. Time deleting the oldest value and adding a new value. So this is something which is there, and if you see the analysis, actual data is in blue color, and 5-year moving average is in the red color, and 4-year moving average, which is the center of that, it's in green color. So this is the manner by which we have make the moving average, and we have seen that how we have made how we have deviated the figure from the actual data. So a moving average is commonly used with time series data to smooth out short-term fluctuations and highlight long-term trends or cycles. The threshold between short-term and long-term depends on the application, and the parameters of moving average will be set accordingly. So what we have observed that there are certain examples. It is often used in technical analysis of financial data like stock prices, return or trading volumes. It is also used in economics to examine gross domestic product, employment or other macroeconomic time series. So there is a great use of the time series as far as the trend is concerned. And if you talk about measure of trend is concerned, I think there is a massively used, and it is not confined to particular domain or segment, but you will find out it had a great variations, and wherever the data is in gamut, data is in big shape, I think there is a good use of all these aspects. So mathematically, a moving average is a type of convolution, and so it can be viewed as an example of a low pass filter used in single signal processing. When used with non-time series data, a moving average filters higher frequency components without any specific connections to time, although typically some kind of ordering is implied. So this is a way by which, and the least square method is also another form of mathematical regression analysis, and which is also used for this measurement of trend, and this is also considered to be one of the way of measuring the trend. So the least square method is a form of mathematical regression analysis that finds the line of best fit for a data set and providing a visual way of doing the thing. So the linear fit that matches the pattern of a set of paired data as closely as possible, and out of all possible linear fits, the least square regression line is the one of that has the smallest possible value for the sum of the squares of the residuals. And demonstration of the relationship between the data point is very important. And if you talk about the methods of least square, is a standard approach to approximate solution of over-determined systems, that is sets of equations in which there are more equations than unknowns. And least square means that the overall solution minimizes the sum of the squares of the errors made in the results of every single equations. And the least square method is usually credited to Carl Friedrich Gauss, which was formulated in the year 1795, but it was first published in Adrian Mary Legendre journal. So if you go more into the backdrop of least square method, this is the best method for obtaining trend values. It provides a convenient basis for obtaining the line of best fit in a series. And line of best fit is a line from which the sum of the deviation of various points on its either side is 0, and the sum of the squares of deviation of various points on the line of best fit is the least. So that is why this method is known as the method of least square. So if you go more into the backdrop, you will find out the method of least square is standard approach in regression analysis to approximate the solution of overdetermined systems by minimizing the sum of the squares of the residuals made in the results of every single equation, and the most important application is in the data fitting. So least square also used in regression analysis, which we have already talked about, and determines the unique trend line forecast, which minimizes the mean square of deviations. The independent variable is the time period, and the dependent variable is the actual observed value in the time series. So if you are going to formulate the equation of straight line trend, I think the equation could be y is equal to a plus bx. So this is the way, and if you see this particular image, I think what we have seen that the given data points are to be minimized by the method of reducing residuals or offset of each point from the line, and this is the best fit line which we have created, and we have first plotted taken the variables on the basis of x axis and y axis, and then the best fit line is going to be created. So if you see this best fit line, the vertical offsets are generally used in surface, polynomial and hyperplane problems, while the perpendicular offsets are utilized in common practice. So if you see the vertical offset, this is this, and perpendicular offset is this. So by this way, we can able to do that. So the most important application is in the data fitting. So this is if you talk more into the depth of least square method, the best fit is the least square sense minimize the sum of squared residuals, a residual being the difference between an observed value and the fitted value provided by a model. And when the problem has substantial uncertainties in the independent variable, the x variable, then simple regression and least square methods have problems. In such cases, the methodology required for fitting errors in variable models may be considered instead of that for least squares. So on the other hand, we have certain merits of least square method. The method gives the trend value for the entire time period. The method can be used to forecast future trend, because trend line establishes a functional relationship between the values and the time, and this is completely objective method. And if you go more to the backdrop, you will find out there are certain shortcomings or pitfalls, rather we can say, as far as the least square method is concerned. It requires some amount of calculations and may appear tedious and complicated for some time or in some of the cases. So future forecasts made by this method are based only on trend values. Seasonal, cyclical or irregular variations are ignored. If even a single item is added to the series, a new equation has to be formed, and this is something which is there. And on the other hand, we have another form of measuring of trend is concerned, which is called curve fitting method. So in regression analysis, curve fitting is the process of specifying the model that provides the best fit to the specific curves in your data set, and curve relationship between variables are not as straightforward to fit and interpret as linear relationship. So now the question is that why is curve fitting is going to be used? Because curve fitting is one of the most powerful and most widely used analysis tool in origin, and curve fitting examines the relationship between one or more predictors, that is independent variable, and response variable as a dependent variable. We have a very important session which was focused on dependent variables and dependent variables, and if you go more into the backdrop of regression analysis and try to compare the simple regression analysis with the multiple regression analysis, I think this independent variable is going to play a very important role, because dependent variable is fixed in both the cases, but independent variable is varies. If you have got more than one independent variable, you can switch over into the multiple regression analysis. So this is one of the best fitting examines way by which you can make the relationships and create a model. So curve fitting is the procedure of constructing a curve or mathematical function that has best fit to series of data points, possibly subject to constraints. Curve fitting can engage either interpolation, where an exact fit to the data is required, or smoothing, in which a smooth function is constructed that approximately fits the data. Fitted curves can be used as an aid for data visualization, to infer values of function where no data are available, and to summarize the relationship among two or more variables. So extrapolation refers to the use of fitted curve beyond the range of the observed data and is subject to a degree of uncertainty, since it may reflect the method used to construct the curve as much as it reflects the observed data. So if you see, I think this is the way of the curve fitting method, and the message or the figure you can very easily visualize that how the linear curves are going to be depicted, how the quadratic curves are going to be depicted, or logarithmic curves are going to be real. So this is a way by which the things are going to be there. And how do you make a curve fit perfectly? In order to make a perfectly fit curve, we must consider error estimates as well, and perfect means the curve should fit the original curve without showing any errors, such as centering and scaling errors in that particular degree of polynomial. So perfect fit can always be a best fit, but best fit cannot be a perfect fit. So anyway, I think we have very elaborately talked about the time series in our preceding sessions, and this particular session was emphasizing more on the measure of trend. So there are certain methodologies which we have talked about, either it could be the moving average or the least square method. So these methods are quite important when you are going to find out the trend, because data is quite gigantic in nature in the present scenario, and if you are going to get the results or depict the particular picture on the basis of gigantic data, I think these methodologies work as a driving force behind making images, and could be quite useful when you are analyzing the thing in a faster mode. Thank you very much. We have some more thought-provoking sessions in our under the ambit of the block 3, which focuses more on trend analysis, like the index numbers and other the topic which could be quite useful for the learners to get a view about the statistical analysis and research methodology. Thank you very much.